Okay, guys, so these are some more quadratic applications that we're going to do, and I just want to show you because they're going to come as word problems, and I want you to be at least a little bit prepared. So let's do some key things. The first thing I want to do, obviously, there's a formula, and I know it's quadratic because of the d squared. And then it says where f is the number of feet and d is the diameter of the log. How many board feet are in a log with a diameter of 12 inches? So it's telling you d is 12 in that case. This is for number one, part A. D equals 12. So obviously we're going to do 0.77, 12 squared minus 1.32 times 12 minus 9.31. And that's going to be 144 times 0.77 minus 1.32 times 12 minus 9.31. Sorry, this was a minus. And that is 85.73 board feet. Okay, I think it's just F. Yeah, it's just F. So that would be the answer for number one. Then it says, what is the diameter that will produce the minimum number of board feet? Okay, so let's look at this real quick. Board feet must be our y, and diameter is our x, and you can tell because the formula has x squared, excuse me, because d is squared, and that's what x usually is associated with. And so, excuse me, I have hiccups. Since it says minimum, we know minimum means that it's something that looks like this, and so it must be the case that it's this vertex here, where you have x and y. Well, we know that this is x is d, and this is f of d. This is the y value, the board feet. And so if we want to find the minimum number, what is the diameter for the minimum, then we're looking for this number. And remember, we can find that by saying d is equal to negative b over 2a, or d is equal to negative 1.32 divided by 2 times 0.77. And so if I put that in, that's 1.32 divided by 2 times 0.77, which is 0.8571. So if you have 0.8571 diameter, not even 1 inch, that's the minimum number of board feet you can get. Okay, let's look. Number of horsepower, so let's look at the questions. How much horsepower is needed to overcome a drag with 50 miles per hour? So 50 miles per hour is obviously the speed, so S is 50. This is number 2. A. S is 50. How would we solve that? Plug 50 into S. You do 0.005 times 50 squared plus 0.007 times 50 minus 0.031. And you get a number, which is 50 times 50 is 2,500, I believe, times 0.005 plus 0.007 times 50 minus 0.031. That is 12.81 or 82. So you did 12.82 horsepower to overcome a wind drag, if it's traveling 50 miles per hour. Okay, and then it says at what speed will the car need to travel to use 200 horsepower to overcome the wind drag? So if we know NS is 200, then we have this formula equal to 200. We subtract it. So this is 0 is equal to 0.005 s squared plus 0.007s 200.031. And if we go from there, then we have to use the quadratic formula. X equals negative 0.007 that's that 20031 number all over 2 times 0.005. And if I do all of this, so this is going to be plus 4 times 0.00 times 200.011. Okay, so that's 4. This is negative 0.007 plus or minus the square root of 4. 2 times 0.005. So this is 0.007, well, negative 0.007. If I subtract, that's going to be negative. We won't have a negative speed, so let's use the positive plus 2. And then divide that by 2 times, 2 times 0.005. And we get that's 200. So that would be the speed we would have to travel in order to overcome that. Wait, what? At what speed is 200 miles? Okay, I'm going to check on that. I'm going to do this. I haven't worked this out beforehand. I'm not sure if that's right. That seems too fast. I must have done something wrong in my calculation, but I will get another video out to you in just a second. Thank you.